Now, as we discussed earlier, like edge is something where the image intensity or the image pixel value is changing. Okay. So, and again, this is like an example of roof edge, which we discussed earlier. The pixel value is changing, then again, it's coming down. Now, if you try to slice a single row from this image patch and try to plot that as a one-dimensional function. So we talked about like the intensity profiling, right? So let's say we draw intensity profile of this with this row. So it will look something like this. Because starting from the left, it's all white, very high. It's kind of bright pixel. So the values will be high. And suddenly you can see that there's an edge and it's becoming darker. So it will go down and then it stays the same. This corresponds to the center location here. And again, it will rise. And it stays the same as the initial level. Okay, so if you draw this intensity profile of this particular row from this patch, it will look something like this. Now, by just looking at this, you can say that, okay, I mean, we have a sense of where the edges are present. We can say that, okay, I mean, the pixel values are changing here, so definitely there is an edge. And we can say that pixel values are changing, there is an edge. Okay, so let's try to see like how we can extract these edges automatically. Considering this as a one-dimensional function, if you compute first order derivative of this function, you will get something like this. I will walk you through like how we get this plot. Starting from the left, so first just a quick recap. Let's walk through like how we can get first order derivative of this function, which is coming from this image patch. And just a quick recap, derivative is just computing whether the function value is changing or not. Okay, so that's exactly what first order derivative was. So if we start from the left and we start moving right, so for each consecutive locations, we will compute whether the value is changing or not. So we can see value is not changing. So the derivative is 0, right? So this is the 0 level and it will remain 0 until we reach this point. Okay, so this is 0. And as we move forward, we can see the value is actually going down. So if you compute the difference, it's going to be a negative value. And as you keep moving, you can see that the slope is actually increasing. And you also know that from your high school maths, derivative kinds of also reflects what is the slope of your function at any given point. Okay, so if you know that, then you know that the slope was actually 0 when we started, and the slope is actually increasing. And if the slope is increasing, it's going in the negative direction, which is fine. That's why we are going in the negative direction. And at this location, when we reach here, it's kind of the maximum slope which we are observing. And this location is exactly at this point. When if you will draw like the tangent to this curve, tangent again gives you the slope. So this tangent, the value will be maximum, the absolute value. All right. And again, as we move forward, the slope of that tangent will again gradually start decreasing like this. And it will be exactly the replica of what we observed before this point. And again, this is the slope was like this. It was increasing, it became maximum, and then it again coming back. All right. So that's the maximum. Again, it's coming back. So it will again come to 0. And this point is at this location, when again the values are not changing at all. So the derivative stays 0. Okay. And again, you can repeat the same process for this curve. And again, this is actually increasing. So your slope is positive. And that's why you get the same kind of bump, but it's in the positive direction. Okay, so that's how you compute first order derivative of this simple intensity profiling. And if you look at this, by looking at this curve, we knew that, okay, this is an edge and this is an edge, but we didn't know like how to automatically compute that. But after computing first order derivative, looking at this, you can easily automate this. You can say that, okay, whenever there is a dip or whenever like we see like a hill, that's an edge, and which is actually true. So this edge over here belongs to this vertical edge, and this edge over here belongs to this vertical edge. Okay, so which means that first order derivative actually helps you in computing edges in your images. So these two peaks are kind of indicating where the edges are.